All right, welcome. First of all, can you guys all hear me okay? Audio is good? All right, great. Well, thank you very much for coming. I'm Andrew Bragdon, and I'm here today to show you guys a whole bunch of brand new features in Visual Studio that are completely new. They are novel within the marketplace. You're not going to see these features anywhere else, and they will be first to market in Visual Studio. All the features you're going to see here today are really focused around making developers more productive. Also, every feature that you see here today is in the preview release of Visual Studio that is now available for public download. So you'll be able to try out everything that you see here in this talk. In fact, I'm going to be mostly demoing today, so it's going to be demos that you'll be able to try out. Before I get started, I'll tell you just a little bit about myself. I'm a program manager on the Visual Studio Application Lifecycle Tools team. And I work on a lot of the features, actually, that you'll see demoed here today. Before that, I was in academic research. I did a lot of research work into information visualization, and in particular, applying InfoViz to developer productivity problems. For example, I did Code Bubbles, which was a visualization tool for developers to show multiple fragments of related code at the same time to the developer, and the idea was that you could see all the fragments relating to your current task. And actually, a lot of the features that you're going to see here today are very much in that vein of applying InfoViz to developer productivity. So this talk is going to be about 95% hands-on demos, but first I just have a few quick slides to get through. I'd also like to ask you at the beginning to please hold your questions for the end. It's kind of jam-packed here with demos, and I'm not sure I'll be able to fit within the allotted time, but I'm going to try to do a good job of saving time at the end to do questions, and also hang around after if you'd like to chat one-on-one. All right, so at Microsoft, we're seeing a lot of challenges that are common to developers. And one that we've seen that's really almost universal, I think, to any development team of any size is that over time, you very quickly accumulate a larger and larger code base. And what that means is that pretty soon you get to a point where a given developer does not know all of the code, and very quickly you also get to the point where even when you union the knowledge of all the developers on the team together, they don't know all the code. A given developer who wrote a key component may move on to another team, or there may be old code that a given developer doesn't really remember that well because they haven't been in there for a long time. And at the same time, with the rise of agile software development, developers are expected to deliver very high quality software frequently, and with the sort of concurrent rise of continuous delivery, expected to actually ship that out to users and customers and get that software out there and actually respond to customer feedback quickly. So when you put all this together, it really kind of creates a knowledge problem. There's too much to know, too much to remember, and it's really hard to keep it all straight. So what I want to do today is I want to drill into that general problem and kind of attack it from a few different angles, okay? And the first angle I'd like to come from is starting with an observation about human beings. Not developers. I'm a former researcher, so just talking about humans. What does it mean to be a human? Well, one of the things that is fundamental to be a human being, even if you are a genius, you have limited working memory. So what that means is if you're working on a development problem, you're writing some code, you only have between, on average, 5 and 7 slots in your mind in which you can store information. So for example, let's say you're working on a function, you need to remember things like, where did I come from? What functions do I need to go to next to modify? Don't forget to go initialize that variable with a different value now that I'm using it a different way. Don't forget to tell Kathy about the changes I'm making, et cetera, et cetera. And so you only have between 5 and 7 slots to store all that information. So that by itself is not a huge problem. But there's a couple other points I'd like to make. One is that the file-based text editor is the universal interface paradigm for all developers. Doesn't matter what tool chain you're using, you're probably using a text editor. And text editors have not changed in a very, very long time in a fundamental way. In fact, what text editors are really good at doing is they're good at showing you one location in one file at one time. Now you might say, well, in Visual Studio, I can split and I can have multiple files up at the same time. This is technically true. Most developers don't do that, however, and the main reason they don't do it is that they perceive the amount of work that is needed to kind of fiddle around with the UI and get it to split the way they want and do all of that is greater than the incremental benefit that they're going to get. So most developers, most of the time, have a single file open, and they use tabs to switch, and they use the back and forward buttons to navigate around. So this also is not by itself a problem. A third observation I'd like to make is that in modern object-oriented software, and this is really a problem that's come about, or really not a problem exactly, it's a feature that has come about with object-oriented software. And what that is that features are no longer localized in one place. Features are spread around in different locations. And this is not just my opinion, it's actually been well studied. And the research has shown, for example, one study took a spec for a large product, and they identified all the requirements in the spec. And for each requirement, they tagged all the methods relating to that feature, okay? And what they found was that on average, the average feature was spread across 15 methods in 7 different classes. And no one feature was localized entirely in a class, single class, and no one single class comprised an entire feature. But rather, you had cross-cutting concerns where features are spread around. And if you think about it, it makes sense, right? Take an example like the model view controller paradigm, right? You're going to naturally spread features across those different places. So this, again, by itself is not a problem. But when you put all 3 things together, it really creates challenges for the developer. You start out with a human being who has very limited working memory. Then you add on to that the fact that you have a user interface paradigm that is really good at showing you one place in one file at one time. And then finally, you combine that with software that is inherently spread all over the place across 15 different methods on average in that one study. And what happens is the average human being starts navigating along through the 15 methods, and eventually they get to the point where their 7 slots are full, and they immediately, by definition, start forgetting stuff because they cannot store more than that. So they start forgetting where they started, they start forgetting where they're going to next. Pretty soon they get lost and disoriented. Typically what we see in the lab when developers get to this stage is they backtrack. They backtrack all the way to the beginning where they started, and they will then kind of repeat what they just did, which is obviously very wasteful. But this time they'll usually try to be more careful. They'll take notes. They will navigate less. They know, okay, maybe I'll skip that method this time. So they use coping strategies to try to deal with this fundamental problem, which is that they can't remember everything that they need to remember because it's too much. So what I'd like to show you now is a brand new feature in Visual Studio called CodeMap. And the idea of CodeMap is we want to solve this problem. And the way we want to solve it is by offloading all this navigational information out of your mind, out of your working memory, and offload it onto the development environment so that you don't have to remember it at all, and you can just focus on remembering the things that are actually relevant to your problem solving and your task. So I'd like to demo this in the context of a bug fix. Here we've got an application called Paint. It's a WPF Paint program, and I can kind of come in here and scribble around. And when I click undo, it's supposed to undo the last stroke. But as you can see, it doesn't work. And when I draw the next stroke, then the undo happens. So it's kind of a weird thing where the undo is kind of delayed. So not knowing anything about this particular code base, I've been tasked with going and fixing this. And so what I'm going to do is I'm going to do a search, like many developers do, for the word undo, because that's a natural place to start, right? Well, the last one in the results list here is a method that looks like an event handler. That looks like a good place to start, because I remember clicking an actual undo button. So I'm going to click on that, and I'm now looking at this method. Now, as a developer, I'm in this unfamiliar code. I'm already feeling uneasy, right? Because I've got this large code base, potentially, and it's complicated. I don't know anything about it. I don't know how it works. I don't know what's important. I don't know what's not important. So I'm feeling a little uneasy. It's not like I'm in my own home code base where I feel really comfortable. So I want a little assistance to kind of get me through this. So what I'm going to do is I'm going to right-click on Undo Canvas Executed, and I'm going to say Show on Code Map. And what this is going to do is it's going to create a small diagram on the right-hand side of my screen. And that diagram is going to help me navigate through this code without getting lost. Now, right now, I only have one thing on the diagram, so it's not helping me very much. So let's keep going. I'm in Undo Canvas Executed, and you can see here there's a call to the undo function. So I'm going to show that on the code map. You can see when I do that, now I have two functions on my diagram, and I have an arrow going from one node to the other. And what that tells me, if I hover over with the tooltip, is it tells me that there's a calling relationship. Undo Canvas Executes calls undo. And I can actually double-click on undo, and that will navigate me on the left side to the function. So far, the diagram is still pretty small, so it's not helping me a lot, but it does show me where I am. I have this little green check mark here, and that tells me, kind of like on a map, where I am. So I'm going to just keep going. I'm in the undo function. The first thing I see here is a variable called paint objects. So I'm going to show that on the map. And by the way, we have a keyboard shortcut. I'm just going to keep using the menu because it's a little clearer, but there is a keyboard shortcut that you can do with one hand. So I've got this variable, and I'm wondering, who else uses it, because the undo function is writing to it here. So I'm going to right-click on Paint Objects, and I'm going to do Find All References. And what this is going to do is it's going to incrementally add to my diagram all the other methods that use this variable. Okay? So I see that there's a call to this function clear that uses paint objects. So let me double-click on clear. And I'm kind of wondering, before I read clear, like, what is this? Where is this coming from? Who uses that? So I right-click on clear, and I choose Find All References. And by the way, this type of behavior where you do a Find All References and then another Find All References is a very common type of exploratory behavior. But notice that with the diagram, instead of clearing the list each time I do it, it adds to it. So I can build up my context. So when I go to Clear Canvas Executed, I can see there's only one green result. It looks like just a straightforward event handler, and it just calls clear. Okay, so that tells me basically there's some kind of user button, and it's calling clear. And clear, if I double-click on it to go back, is doing some stuff, and then it's clearing this variable, paint objects, and then it's calling repaint. So let me just keep going. Let's see who else uses paint objects. There's paint canvas, which looks like a constructor. So I'm going to just skip that because it's not doing anything too interesting. And then there's one more function, add paint object. So let me double-click on that. Now this method is modifying paint objects, and then it's calling a repaint function. And it's modifying paint objects by adding in this parameter value, new object. So naturally, I'm kind of wondering, where does that come from? So I'm going to right-click on Add Paint Object and do Find All References. And I see one result, construction complete, so I'm going to kind of work my way up. Okay, construction complete, takes in a parameter, final object, and passes that into Add Paint Object. There's another very common thing in code, right? You have functions that just kind of pass values through. So we're going to just kind of follow up the chain. Who uses construction complete? So we got another call here, mouse released. I'm a GUI developer, so I kind of recognize this. This looks like a event handler. And it's defining this temporary object with points gathered. And just kind of remembering back to the app, this is a drawing program, so you can recall when you scribble, that's probably what points gathered is. And I can see that that's going into this temp object, which is then getting passed into construction complete. So if I follow that back down, construction complete takes that in and then passes it down back into add paint object. And add paint object adds that to paint objects, big surprise, and then it calls repaint. So I'm wondering, okay, what's repaint? So let me show that on the map. Now this is kind of interesting. Repaint is actually already on my map. I just didn't happen to notice it, so it just gets highlighted, right? And I can see very clearly on the map that add paint object and clear are both calling repaint. But undo, which is where I was earlier, there's no arrow. So let me double click back there. I can see, in fact, undo, sanity check here. Undo does not call repaint. So I'm wondering at this point, I kind of have a theory. I wonder if undo should be calling repaint. So the other thing I can do with my map is I can flag things to take little notes to myself. You know, maybe this function is important, maybe that one is important. And I can also add little notes. So I can right click and I can say new comment. I can say, shouldn't this call repaint? So now that I've kind of offloaded a little bit more out of my memory, you know, I put some notes on there, what I'm doing, what's next. I've put that on there, now I can get it out of my head. I also don't have to remember all this stuff. I mean, if you look at this map, there's quite a bit of stuff on the diagram. I don't need to remember it now. So I'm going to just come over to undo, and actually first let me just save my diagram. I'm going to put it in my documents folder. This is an open XML file format called DGML. You can actually generate your own diagrams if you want to and take advantage of our layout engine. I'm going to just come over here and add a call to repaint. So let's try rebuilding that, and let's just see if that fixes the bug. So I'm going to run my program, draw a couple strokes, and lo and behold, undo works again. Okay, so at this point, I kind of have a little more work to do. I probably want to investigate the issue a little more before I actually check it in or send it out for code review or whatnot. And right at this moment, you know, maybe I set a breakpoint to double check something. My boss, Peter, comes into my office and he says, hey, Andrew, I got a really high priority issue for you in Eraser Paint. Nobody else is around right now. We're getting a lot of support calls. I need you to go do it right now. So it's pretty inconvenient because I'm kind of half done with my task here, right? I'm not done. I've got all my context here. I kind of got my change made, but I'm not done yet. So I'm going to come over to Team Explorer, and I'm going to hit suspend. And that's actually what this is going to do is it's going to back up all my changes, all the windows that I had open, all the breakpoints I had created. It's going to back all of that up to the server and put it away. So I'm now back at a clean slate. So that call to repaint that I added, for example, is gone now. So now I can go do something else, right? Like investigate Eraser Paint. You know, and maybe I work on this for a couple hours. I get it out for code review. It's done. I have lunch. I check it in. Now it's 3 hours later. I'm done with the task. I remember that in the morning, I was working on that undo thing, but I can barely remember what I did. Well, I can just come back to Team Explorer, go back to my work, and I just select that unit of work that I suspended 3-4 hours ago. I hit resume, and it's going to do the inverse of what it did earlier. It's going to put everything back the way it was. It's going to take the changes that I had, put them back into my workspace. It's going to reopen all the windows I had, recreate all the breakpoints I had, and it's going to open my map again. Now, I didn't create the map to help me resume my task, but the map is going to be really helpful right now because it includes all kinds of stuff that was sort of in my head, if you will. It has where I was navigating. It has the things that I flagged as being important. It has this comment that I created. All of that is rehydrated, and it's going to make it a lot easier for me to resume my task. So just now we've seen CodeMap and how it can help you navigate through and implement complex changes. We've also seen my work, which can help you suspend and resume, and we've seen the CodeMap integration with my work. What I'd like to show you now is sort of the result of customer feedback. So we started testing CodeMap here, and sort of two big pieces of feedback came out of the lab studies. One was, we like it, it's definitely helping, and the second one was, can you please make this work for the debugger? A lot of times, developers say they use the debugger to do this type of thing, where they step through unfamiliar code. The debugger helps them a little bit, but they still get lost a lot because you step through 9 functions, now you can't remember the first 2 anymore. So actually, the next feature is called CodeMap Debugger Integration, and it's pretty much exactly that. Based on the customer feedback, we looked at it, And so what I have here is a different app. This app is a little bit more complicated from an implementation standpoint. What it is it's a parser and evaluator for expressions. So I can type in, math expressions, press enter, and it's going to evaluate them and print out the result. So I can actually type in here 3 mod 2, and you can see that it outputs the wrong answer, 0. Of course, the correct answer is 1 because 3 divided by 2 has a remainder of 1. So in this case, this is kind of a complicated runtime program. It's natural that you would want to use a debugger. So what I'm going to do is I'm going to come back to Visual Studio, and the only thing I really know about this app is that it has a main function because it's a console program. So I'm going to search for main, and excuse me. You can see there's a bunch of console kind of right line stuff. Okay, not too interesting. And then there's a call to execute here. So let me just set a breakpoint, and let's just kind of debug this using the Visual Studio Debugger. So I'm going to re-enter my expression here, press enter, and of course I hit the breakpoint. So what I can do now is I can take advantage of CodeMap debugger integration because just like before, I'm feeling a little uneasy as a developer. This is a complex code base. I don't know how it works. I don't know what's important. I don't know what's not. So anything that's going to help me kind of navigate through that is going to be a big help. So I come up here, and on the debugger toolbar, there's a new button, Code Map. And when I click that, what it does is it takes the call stack and it projects that automatically onto the diagram. Now, of course, right now I have the world's simplest call stack, right? I have external code and main. Doesn't get much simpler than that. Now, it has a couple other things that I'd like to point out. You can see that it shows that there's a breakpoint here, and also that this is the current instruction pointer, just like in this call stack, just like in the editor. So when I click the Step Into button, it's going to continue to automatically update itself. So I didn't have to do anything. I just clicked the regular Step Into button, and the diagram tracks what I'm doing. So far, still, diagram is pretty simple, right? It's not telling me a lot. So I'm going to just keep going. So there's a call to parse. OK, let's step into that. Looks like there's this call here to tokenize line. Let's step into that. So now, at this point, something interesting has happened. You can see on the diagram, there's an edge label there that says external code. And I'm wondering, as a developer, what does that mean? Why does it say external code? And I can also see that on the call stack, it also says external code. So what I can do is I can just double-click on the parse function. And that is going to change the current call frame. And I'm now in the parse function. It's going to show me the exact line of code that's on the stack. And the locals window, of course, is going to update to reflect the parse function. Now I can see that tokenized line is called here through add range. And add range is looks like maybe some .NET lazy evaluation is happening here. So tokenized line is getting called indirectly through the framework, and that's where you get the external code. So I'm going to just go back to tokenized line now that that great mystery is solved. And I'm just going to scroll around in here in this function. This is a pretty long function, right? I can see there's go-tos in here. That's probably not good. Not usually a recommended best practice. Quite a few go-tos, in fact. Looks like about 100 lines of code. This looks pretty nasty. Now, I just started debugging, right? And I was kind of happily going through nice short functions. Now I'm in this giant nightmare. I don't want to debug this right now. I would do anything to debug this later. So what I'm going to do is I'm going to come over to my diagram, and I'm going to say new comment, okay? And I'm going to put nasty, could be buggy, okay? And that's going to be my little to-do to come check this out later, maybe. But really what I want to do is I want to get out of here and see if maybe the bug is in someplace nicer. So I'm going to hit step out. Now, when I hit step out, something interesting is going to happen in that you can see tokenized line still in the diagram. Tokenized line, of course, is no longer on the call stack because I hit step out, so it's not in the call stack window. But it is still on the diagram. And this is important. You know, if I were using the call stack and I were stepping through here, pretty quickly I'd probably forget about tokenized line completely because it wouldn't be anywhere in my UI anymore. and I would have to mentally remember that, but I'm going to be too busy remembering other things, I'd probably forget it. Here, though, it's automatically preserved. I didn't have to do anything to keep it. The fact that I added a comment is not the reason it's still there. It's preserved automatically. And of course, my comment is still there as well. So I can just keep going. I'm going to keep stepping. I see there's a call here to parse statement. Let me go in there. You can see now my diagram is forming a tree because, of course, it's branched there. So I'm going to just keep going. There's a call to peek token. And it looks like what this is doing is it's going to return sort of a future token. So that might be interesting. I don't know. I'm going to step out, kind of leave it there. We can check it out later if we need to. Let's keep going. Now there's a call to parse expression. Let's step in. And parse expression immediately calls parse term. So let's step into that. And that immediately calls parse factor. So let's step into that. Now I'd just like to point out that at this point, if I were debugging manually, it would start to become pretty disorienting because you can see there's quite a bit of stuff there on the diagram. If I were trying to remember all of that stuff, it would start to be pretty difficult, right? But it's all generated automatically. I didn't do anything to create the diagram. I just turned it on, and it's just following along. So I'm going to keep stepping, keep getting even deeper in here. Next token, I wonder what that does. So this is going to advance this variable. It looks like it's going to return the next token. Okay, so let's step out. And then it calls push. So let's step into that, see what that does. Now, push is taking in a value 3, and it's pushing it onto this data stack. This data stack looks interesting to me. I'm sort of wondering, am I going to encounter this again? So I'm going to just right-click on it and say Show in Code Map. Now notice that Code Map debugger integration and Code Map are deeply linked together. So anything that you can do in Code Map, you can also do in Code Map debugger integration, like add things of interest, like I just did. I can right-click on data stack and say Find All References, for example. Any of that type of stuff I did earlier, I can still do that. But for now, I'm just going to keep stepping. I can always do that later. So I'm getting to the end of parse factor. So I'm going to hit step out. Notice again when I hit step out, it's sort of like the light bulbs are turning off, right? In that, I'm popping up the stack and I can see that visually. So I'm going to keep stepping here, and it's another call to peek token. Don't care about that. See what we get. Okay, another call to parse factor. Let's see what that does. So we step in, and this is a good time to mention, by the way, that this is a slightly easier version of a real problem that we gave professional developers in a lab study. So we recruited professional developers from the Seattle area. They came in, we gave them an hour and a half. We gave them the full power of Visual Studio to solve a slightly harder version of this problem. And they couldn't do it after an hour and a half. The code was alien, it was too much, and they really had a bad experience, actually. After an hour and a half, they couldn't do it. We then recruited a second group from the exact same population, same general skill level, and we gave them the same problem. This time, though, we gave them Code Map debugger integration, and they were able to solve it in about 45 minutes. So having this to step through this sort of almost nightmare of recursive stuff really made a big difference. Now, you can see here there's a call to push, so I'm going to step into that. And we've got a value here, 2. So if you recall earlier, we pushed to 3, now we pushed to 2. Okay, looks like we're making some progress, so let's step out, and let's keep going. Now there's a switch statement that switched on op value, and op value just happens to be modulus, which looks very familiar, right? That is the 3 mod 2. And so now we're getting somewhere. So there's a call here to pop. Let's step into that. So see what that's going to do. That is going to return this value here, 2. And I can also see now in my map I've got pop and push, and they both reference the same data stack. Okay. So let's step out. So we have another immediate call to pop. So now we have 2, and we have 3. And then we have this line here that is calling pop again, and then is actually using the C# modulus operator. So we know we're getting close. to something interesting, and then first. Now the thing is, if I double click on DataStack here, the value is currently actually empty. It's a stack, but it has a count of 0, right? There's nothing in here. And I can actually double click back on parse term to go back. So it's actually going to push nothing mod 2. So that's probably wrong. So we have sort of a theory. So what I'm going to do is I'm going to hit stop. And let's just try changing that to be second, because this is a variable that is not even getting used, right? It's kind of weird. Let's try rebuilding that and running it again. Okay, 3 mod 2. And actually, this is notable. Remember, I didn't clear my breakpoint from earlier. So I've actually hit that. The code map lives on beyond the debugger session. So when you hit stop, it doesn't go away. When you start debugging again, the same map is reused unless you clear it. So I can actually see that where I currently am is at the beginning of the journey I had started earlier, right? So if I were to re-step through, I could actually step my way right back through if I wanted to. But right now, I just want to see whether I was right. So I'm going to hit continue. And in fact, lo and behold, the answer is 1. So it looks like it's working. So at this point, I'd just like to point out how there's a lot of stuff on this map, and almost all of it was added and updated automatically by Visual Studio. I did not have to do anything, pretty much. I added a comment, and I added DataStack. That was it. And this map, in some ways, is self-documenting. I can go to Share, and I can hit Email. I can save it in various portable formats. DGML is a file format that most versions of Visual Studio can open as well. I can also copy it as a picture. So if, for example, I went back to my work, and if I had a bug for this task, I could paste the picture in as documentation. And this is actually a PNG, so it's very portable. So I can actually do quite a bit with the diagram once I've got it. All right. So with that, I'd like to flip back to Visual Studio. So we just saw debugger map, or code map debugger integration, that is, and how it can help you step through very complicated code, even code that you know well, and try to keep track of it without having to remember every little detail about where you came from, where you're going. You can add important things to it, and notes as well. All right. So now, I'd like to talk about a different but related problem. Let's say you're working on a piece of code, say a function or a class. It's very likely that you're going to have questions about the code, right? Some common questions that you might have are, who wrote this code? How many changes have there been to this code? What do those changes look like? Has there been a lot of churn in this code? Is there one person who's sort of the expert in this code? Like if I had a question or I wanted to get some feedback, who should I go talk to? Are there any unit tests that cover this code? If there are any unit tests, what's their status? What other code depends on this code? So if I were to change this code, what other code might be impacted? These are all very common questions, and they all have one important thing in common, which is that you cannot answer any of those questions by reading the code itself. If you want to answer those questions, what you have to do is you have to stop your current development task, okay? And you have to go off and do some digging. For example, suppose the question you're trying to answer is, who's the expert in this function? One way you might do that is you might go back digging through your version control system to try to figure out who that is. If it's a 3-year-old function, that may be a non-trivial task. Another, maybe even more likely way to do that might be you might ask a colleague. You might go ask the guy across the hall. He doesn't know, but he thinks maybe Bob does. So you go over to Bob's office, but he's at lunch. So you send him an email. 3 hours later, he gets back to you and says, no, it's not me, but I think Jane wrote that, actually. Why don't you talk to her? So now you've gone from being in the zone, writing your code, solving real problems, to doing a bunch of crap work that has completely taken you out of your development. What I'd like to do now is introduce a brand new feature in Visual Studio that is designed to completely rethink this problem. And that feature is called CodeLens. And with CodeLens, we want to completely rethink how you answer common questions about your code. instead of interrupting yourself and doing all this drudgery work, we want to make highly relevant contextual information about your code available at all times ambiently with 0 clicks through a developer heads-up display. So let me show you what I mean. So I'm going to go back over to Visual Studio, and I'm going to click on Fabricam Fiber. Now this is a web app, and in this scenario, I've gotten a bug in from the ops team, and I'm sort of on call here. You know, I don't know this app, but I'm tasked with dealing with all the incoming bugs from ops. And so I'm not very familiar with Fabricam, but the bug is telling me that the home page is running slowly and that it appears to be a regression. It didn't used to be slow, now it is. Okay, not an uncommon scenario. And it also, the ops team also mentioned that it looks like this index function might have something to do with it. So again, I'm going to just do a quick search for index, see what I can find here. I'm going to open this up. Now, I have the code as I normally do, but there's one very important difference. So I'm just going to zoom in briefly to emphasize this. Above the method, you can see there's a line of contextual data. That line of contextual data is CodeLens, and that line is composed of different indicators that tell me different important things about the code that you cannot get from just reading it. So the first indicator tells me that index, this index function, is used by 5 different methods. So I can click on that, for example, and I'll get a very lightweight contextual pop-up that shows me that list, and I can actually hover over these items to see actually how they're used. And of course, I can double-click to navigate if I want to. But right now, it's just telling me something kind of more basic, which is that if I were to change index, I might be affecting a bunch of other code, in contrast to, say, index safe, which has 0 references, and so probably doesn't matter. The next indicator is called the tested by indicator. And what this is telling me is that there are 2 unit tests that cover this method index. And one of them is currently passing, and one of them is failing. Now, normally with CodeLens, we want to really minimize the visuals. We don't want to distract you from the code. We don't want to sort of interrupt your code. We want it to be sort of subtle. You can pay attention to it if you want to. You can ignore it if you want to. But in this case, because there's a highly relevant test to this method, and that test is failing, and we know it's failing, we actually show a red icon in this case because we want to get your attention. It's sort of like an error, right? You got a failing unit test, it's fairly serious. So at this point, kind of what I'm wondering is, I wonder if somebody changed this method and didn't run the unit test and then checked it in. So I'm going to actually just click on this indicator, and you can see here it shows the different tests that cover the method, and I can immediately zero in on the one that's failing, and I'm just going to double click on it. Now this did tell me a couple things, right? It helped me discover that there even were tests. You know, if I were to use the Test Explorer, I'd have to go rummaging around in there to try to figure out if there were any tests covering the method. But this way I get told up front, and now I'm in directly into the test that's failing. So just scanning the test, I can start to learn a little bit about the code. It's telling me that there is a performance test here, and it looks like it's going to test this stuff, and then it's going to check to see whether that took 2 seconds or less. So it's actually a performance test. And just to confirm that, I can come up here and click on this red icon, and it's actually going to give me the details of the failing test. So again, I don't have to rummage around in the Test Explorer, it's just right there in the editor. And of course, I can see assert is failed, and it took 7 seconds, which is pretty long. So I'm going to just go back, actually. And I'm now wondering, you know, with this failing test, there could be a couple problems, right? It could be that somebody changed it and broke it. It could be that there's something wrong with the environment, like the database server is being backed up, and so it's slow. But usually the ops team is pretty good about telling me about that. So I'm going to stick with sort of the theory that it's a code problem. The next indicator is telling me that the last person to touch this method is Julia. And I kind of know her a little bit. She's on a different team. But I can see that, you know, if I click on this, here's the changes that have been made, and they've all been made by Julia, actually. So it looks like she would be a good person to talk to if I had a question. In fact, I can hover over her name and her email address here, and you can see that it turns into a hyperlink. And if I click on that, it's going to actually open my default mail client and pre-populate it with a bunch of useful information, like her email address, some details about that particular change set. There's a contextual hyperlink here. I can actually click on that, and it's going to actually open a very portable web view of that change set. So if she were on a tablet, she could review it. She doesn't even need Visual Studio. But I'm not quite ready to email her yet. I don't know whether she caused the problem or not. And I also don't know what I want to ask her quite yet. So let's just explore what she actually changed. So the most recent change here says added some test code. So let's just double click on that. Now when we double click on it, a couple things are going to happen automatically. One, it's going to download the right diff of the right file, and it's going to scroll that method index into view automatically, and it's going to take me to the first change in that method. So if there's 100 other changes in a very long file, it's going to take me to the right method automatically. Second, it's also going to open the change set details on the right. So I can see, who wrote the change set, what its name is, what the comments are, and even what other files are in the change set. But really, in this case, a diff is all I really need because it's showing me that she added this function call here. So I see that's a change. I wonder if that's important. So I'm going to go back, scroll down, and I see this log data call here. So I'm going to go to definition on that. And this one I can see right away is also written by Julia. So that's telling me something. I wonder if this has been changed. So let me check it out. Yep, this has been changed too. And she said she added some hardening. Let's see what that was. So she looks like she added some null checks here. It's pretty easy to see that. Let's see what she changed before that. So here we've got a bigger block change. And you can see the comment here says logging experiment, add delay to improve logging reliability. So she's got a bunch of thread.sleeps in here. Probably she did not mean to check that into the production branch. So I've kind of got a good working theory right now. So I can, go back to my email, and I can, for example, I could screenshot this, or I could paste it in, whatever way I like to do it. Hey, do you know what the deal with this is? But actually, I'm feeling good, so I'm going to just try turning it off and confirm my theory. So I'm going to just come back here, and here's that call. Let me just turn it off. Let me scroll back up to the beginning of this method. Now, as you recall, the CodeLens indicators are automatically telling me which unit tests are covering the method, and earlier I learned that there's a perf test. So I'm going to just click on one of two passing, and I'm just going to click Run All. And what that's going to do is it's going to do a couple things. One, it's going to notice I changed the code, so it's going to automatically trigger a build. The second thing it's going to do is going to check for any new unit tests. In this case, there aren't any. And then the third thing it's going to do is it's going to run these unit tests first. So if I have 2,000 unit tests in a very large project, it's going to run these that cover only this method first. And immediately I can see that now it's passing. So I have pretty good confirmation of my theory at this point. So I'd like to show a couple other things that you can do with CodeLens. When you see it, one of the things we often hear from developers is, hey, well, how does this affect my typing experience? What does that look like? So I'm going to flip over to another instance of the IDE, and I'm going to open that console calculator app that we had before. Let's try writing a new method in here. So now you can see CodeLens is on. I'm going to go into this execute method. And I can see also that this execute method has 3 tests covering it. And I can actually open this up. Let me just run those tests, see whether they pass. And I can also quickly see, okay, these actually look kind of relevant, right? Addition test, division test, subtraction test. But there is obviously no mod test, and that was our bug. So let's try typing a new quick test in here so we can see what the typing experience is like when you have contextual data. So I'm going to type test method, And then I'm going to do public void mod test. And then I'm going to type enter there. And you saw when I pressed enter, that's when CodeLens decided, okay, that's definitely a new method, and it's going to actually reserve some space for the indicator panel. Okay? And a couple other interesting things here. One of the top priorities with CodeLens is we do not want to disrupt your existing editor behaviors. Okay? So when we added the CodeLens indicator panel in there, you may have noticed that instead of pushing your method down in the editor, we actually shift the code above it upward. And that's, we found, much, much less disruptive because the method that you're working on doesn't move. Okay? Even if you're at the very top of the editor, it'll still go up. So the idea is no disruption. Just to show you a few other things, like if I were to press the up arrow key, I'm right here on this line. You might be wondering, if I press up arrow, what's going to happen? Well, it actually skips right over the CodeLens indicators because they're not part of the file. They're part of the view, and the idea is we don't want to disrupt you. So if I were to, for example, copy this code, paste it in, whoops, having trouble copying and pasting here. There we go. Now let's just change the test. You know, you recall 3 mod 2. Let's try putting this in here. Now, one thing I'd just like to show that's really cool, this is definitely for you TDDers in the audience. If I come into Test Explorer and I turn on the continuous test runner, if I just press F6 to build right in my editor, you can see it's going to immediately discover that new test, immediately run it, and immediately show the status right in the editor. So let me just show that again. If I change this R equal to be wrong, like let's say you change it to 2, press F6, immediately builds, discovers a test, it fails. Now I can actually open the test to see why it failed. And you know, I get all the details right here. I don't like failing tests, so I'm going to put it back, build again, immediately updates. So if you're a TDDer, you can live right in the editor, you can do your unit testing in a very sort of fluid, lightweight way. You don't have to go to the Test Explorer. In fact, you can leave it pretty much completely collapsed if you want to. All right, so another thing I'd like to show real quick is we get a lot of questions from people, you know, who do keyboarding. Well, how does this work with keyboarding? Can I do this through the keyboard? You probably noticed I've been using the mouse the whole time. Well, the good news for you, if you're a keyboard user, is that from the beginning, the design stage of CodeLens, we said keyboarding needs to be a first-class experience in CodeLens. So if I press and hold the Alt key, you can see that numbers appear above each indicator. Okay, and I can then press the corresponding number to activate the indicator. So let's say I want references. I can do Alt 2. Okay, and then I can do, you know, down arrow, up arrow, up arrow. If I don't want to be in here anymore, I just hit escape right back in the editor. Cursor didn't move. Let's say I do Alt 2 and I say, oh, you know what? I actually wanted the test indicator I missed. Well, you can just press the right arrow and you immediately flip over to the next one. If you want to go back, left arrow, you know, I can do right arrow, right arrow. Let's say I want the third change set from Julia. I just do down, down, enter. Bam, and I'm immediately in the right function, in the right diff, and I did this entirely with the keyboard. If you tried to do what I just did without CodeLens, you know, you would be an order of magnitude more keystrokes to get to the same thing. So it's very easy to do the keyboarding. The other thing I would just quickly mention is you can press and hold the Alt key, and when you do that, you'll notice that these numbers are sort of non-mnemonic and that 2 doesn't really have anything to do with references. So these keys, though, are statically assigned to the indicator. So if you're an expert user, you can sort of over time learn that 2 is references or that 4 is the author's indicator. And you can go directly there just using the keystrokes. You don't even have to press and hold. But we have the press and hold there so that if you can't remember, you can just kind of quickly recall on the fly. Okay, so I'm going to quickly flip back. Now, another thing I'd just like to say about CodeLens is that we have gone to great lengths to make the performance of CodeLens be really fast and really fluid. And just to give you a good example of that, you saw the indicators that are kind of mining historical information about your repository, all the change information, for example. The way that works is when a developer does a check-in, it goes into TFS version control, and then almost immediately, the CodeLens indexer is notified, and it will immediately start indexing and analyzing that change set. And will then dump the output into the CodeLens index, which is our primary data store for all the information about CodeLens. And then that is further pushed into a very high-performance cache. And this whole loop takes about 30 seconds or less in a typical case. Just to give you an idea of how well this scales, we use Team Foundation Server and Visual Studio to develop Visual Studio. And so we have a very large number of developers checking in all the time. And this loop takes less than 30 seconds in Microsoft. And we're not running on crazy hardware. In fact, we have sort of under-spec'd hardware to deliberately stress the server. So what you have here is something that goes very fast. So then within 30 seconds, a second developer comes along, opens the file that Julia just changed. They immediately see the most up-to-date information. And the transfer of the data is compressed over the wire. It's actually pre-compressed in the cache. So it's delivered very fast. At Microsoft, thousands of people opening thousands of files per hour. We're seeing, response times well under a second. Typically 500 milliseconds or less. So it's very fast, and we've done a lot of other work to make it really simple. And the other thing I'll just point out is, on this server, this requires zero setup. All you need to do to get CodeLens working on TFS is install TFS. You don't have to manually turn it on. You don't have to configure it. You don't have to use Team Build. You don't even have to know what Team Build is. You just have version control, and it works. And TFS will now be aware of the sort of semantic changes that you're making. All right. So I'd like to quickly review here. So first we saw CodeMap, which is a feature to help you visualize stuff that is relevant to your task, add all of your navigational information onto a diagram so that you don't have to memorize it. And it really helps you kind of deal with complex changes to your own code, exploring other people's code. We then saw how that integrates deeply into my work to get your context management. Then we saw CodeMap debugger integration, which can help you visualize very complex debugging sessions without getting lost, and also requires almost no work to do. You just press CodeMap to turn it on, that's it. Then we saw CodeLens, which is a third brand new feature in Visual Studio. And that is a developer heads-up display for showing highly relevant contextual information right in your IDE in a very sort of lightweight, unobtrusive way, and also has great keyboarding support. Okay, with that, I'd like to thank you very much for your attention. Yes, just 1 second. Real quick, I just want to say, if you like what you saw today, we are offering a limited number of closed doors demos of where we've taken CodeLens since it was snapped for preview, which is released today, and also a whole bunch of new, kind of more future features, none of which are publicly released yet. You will have to sign an NDA, but it's pretty fun. It takes about 45 minutes. Our fantastic usability researcher, Carl, is here. So if you're interested, come up to the front at the end of the talk and see Carl, and he can sign you up for a time slot. We have time slots that are in between talks, so it shouldn't overlap with other things that you want to do. All right, so at that, I'd be happy to take some questions. Would you mind going up to the mic? Because I think it's being recorded, and that way the folks at home can hear.
Hi. You mentioned TFS. Which version of TFS?
So to get the
CodeLens.
Yes. So for CodeLens, we have a bunch of integration in TFS. You will need the newest version of TFS, which will be TFS 2013. Also, TFS Preview, which you all got access to today, will work fine as well and has a Go Live license.
Okay, thank you.
Yes, we use the hosted TFS solution at visualstudio.com. I'm just wondering if CodeLens is a feature that will be automatically implemented there?
So we are working on that,
Okay.
and stay tuned.
Okay. All right.
Yeah.
Great. Thank you.
So for CodeLens, when developer 1 checks in, developer 2 can see it. Does developer 2 have to do a get latest, or does it automatically show up?
That's a great question. So the answer is no. Developer 2 just opens the file, and they will get the latest and greatest data.
What if there are significant changes to the file, like new methods and such?
It will still work if you've made a bunch of local changes. The only thing that will affect that is if you actually change the name of the method. Then it won't actually pick it up. But pretty much any other changes, even catastrophic changes, will still work.
Thank you.
Thanks.
I think I know the answer to this, but was there integration for Subversion? Or anything
It's a
other
great
than
question.
TFS?
Unfortunately, not at this time.
Not at this time. Okay.
Yeah,
thank
you do have to use TFS.
Are you going to roll CodeMap into prior versions of Visual Studio,
Which version of Visual Studio are you on?
2008 or 2010?
Unfortunately, it's only rolling forward at this point. But if you get 2012, you can pick it up through updates. If you get 2013, it'll be right there in the box.
I came late, and I would like to know if the...
I'm having a
This-
little trouble hearing you, sorry.
Okay, I came a little bit late to the section, and I didn't know that if these functions will be available on the Ultimate version or on the professional version too.
So which version is it available in? That's still being worked on, but right now, everything that you see here is in Ultimate. Visual Studio Ultimate.
One more question. Great problem for CodeMap. I looked at it. I mean, we've all been in that situation where we have to debug
Oh, thank you.
unfriendly code. Question, does it support mixed environment? So let's say you're having a web app on the client side calling server side, async mode, and you can kind of map the callback.
Yeah, so the answer is actually absolutely. I forgot to mention this in my talk, but CodeMap debugger integration will actually work for any programming language that is supported by Visual Studio. So it'll work for C#, it'll work for Visual Basic, it'll work for JavaScript, it'll work for unmanaged C++. It'll even work for third-party languages like IronPython, and it will also work with any combination thereof. So you can have C++ calling managed code, calling JavaScript, any combination that the Visual Studio debugger supports, it will work with.
Oh, thanks. Pretty cool.
Cool, thank you.